Minute Math. When you need help, you use Minute Math.
I'm Sean Gannon, and this is Minute Math. Today, we're going to learn about simplifying radical expressions. So if I was given this problem, square root of 125n, okay? So what I like to do is see if I can break down my prime factorization of 125, that number itself, okay? So 125 I know is 5 and 25. Then 25 breaks down to be 5 and 5, okay? So really 125 is 5 times 5 times 5. So what I like to do is I grab pairs, okay? So when I've broken it down, I can't break down each one of these anymore. They're all down to the lowest prime number. So okay, I need to grab a pair. So I'm going to grab a pair of these 5s. I see one pair of 5s, good. I circle, but then I don't have another pair. That 5 is by itself. So the way I think about it, when I bring it to the outside, so if I have a pair, I can bring it to the outside. So I bring one 5 to the outside of my radical, my root, okay? My root there. There's one 5 left over on the inside, so he didn't have a pair. So the 5's on the inside, and then the n is left over because times n is right there, so times n, so n's on the inside. And so now we can simplify from square root of 125n is the same thing as 5 times the square root of 5n. Square root of 216v. Okay, and v is inside the square root as well. So it's 216 times v. So we need to break down the prime factorization of 216. So I know that 2 goes into it, all right, and I'll just use my calculator because it's a little easier here. 216 divided by 2 comes out to be 108. 108 is also divided by 2. We know that because it's even number, so divide that by 2. And 2 times 54. 54 divided by 2, let's just keep going, that by 2s is 27. So we have 2 and 27. And 27 is divided by 3. We have 3 and 9 there. And 9 is divided by 3 twice as well. And there we have it. So what I do is kind of break down prime factorization of 216. That's 2 times 108. And 108 was 2 times 54. 54 was 2 times 27. 27 was 3 times 9. And 9 was 3 times 3. So now I have all the prime numbers that if I multiplied out, 2 times 2 times 2 times 3 times 3 times 3 would get me 216 there. And so now I want to circle my pairs. I have one pair of 3s, I have one pair of 2s, and that's my only pairs, okay? So, let's put it right here. Every pair we have on the outside, so we have a pair of 2s, put 1 on the outside. So these, when I have a pair circle, I'm from the outside by square root, times one pair of 3, that's right there. Inside the square root, I have the singles left over, 2 times 3, 2 times 3, and then times v, which is just left over on the inside. So now we have 2 times 3 on the outside. Square root of 2 times 3 times v is the same thing as square root of 216v. So now I'm going to simplify. 2 times 3 is 6, and then 2 times 3 again is 6, 6v, and there we go. We have a final answer of 6 square root of 6v. It's the same thing as square root of 216v. Square root of 512 k squared. Now I needed to simplify that. Well, we're going to take 512, and I know it's divisible by 2. So I'm going to take 512, I'm going to divide it by 2. Use my calculator here. 2, and that's 256. Okay? If you know your computers, this is pretty easy, right? Divide 256 by 2. I'll keep doing my prime factorization. I have 120, or 2 and 128, the 2 first. And then 128 divided by 2 comes out to be 64. 64 divided by 2 is 32. 32 divided by 2 is 18. 16. Getting ahead of myself there. Oof. 16. 16 is 2 and 8. 8 is 2 and 4. And 4 is 2 and 2. Okay. So I broke it down all the prime factorization of 212. But don't forget k squared, right? K squared is just k times k, right? It's a little side note you want to kind of think about there. So we have our we kind of did a prime factorization of 512, which became 2 times 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 2. So, and then the k squared was k times k. Let's circle our pairs. I have a pair of 2's right here. One pair of 2's. 2 pairs of 2s, 3 pairs of 2s, and 4 pairs of 2s. So every single pair, oh, and a pair of k's too, don't forget that, pair of k's. So every single pair we have, okay, we're going to put outside of our square root. So we have one pair of 2, this first one here, 2 times, I got that one, put a dot there. This one here, pair, put 1 on the outside, pair right here, got that pair, times 2. And then we have a k, so a pair of k's is times 1k on the outside. Just left with this one single lone 2 is on the inside. Square root of 2 right there. So now we simplify. What's 2 times 2 times 2 times 2? 2 times 2 is 4, times 2 is 8, times 2 is 16. So you have 16 here, k being on the outside 16k times the square root of 2. And that is the final answer how we simplify square root of 512k squared. Square root of 512 m to the third power. Okay, so I need to break down 512. I'll do my prime factorization of that. 512 is 2 times 256. Okay, let's just keep going from here. 256, I just did a similar problem. 256 was 2 times 128. And if again, you know your computers, this is easy. 128 is 2 and 64. 64 is 2 and 32. And 32 is 2 and 16. And 16 is 2 and 8. 8 is 2 and 4. And 4 is 2 and 2. So I broke this down to 512 to all the prime numbers I could that we multiplied together to get 512, which is 2 times 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 2. Now, m to the third power can be broken down to m times m times m, right? M to the third is m times m times m. And so now we're going to grab our pairs. I'm going to circle a pair of 2. So I have one pair of 2 here, 2 pairs of 2, 3 pairs of 2, and 4 pairs of 2. M's, I have one pair of M's. Okay? So now that I circle my pairs, okay, I'm going to put them on the outside. So every pair represents 1, 2 on the outside. So we have 2 on the outside, 1, 2. This first one, got that one, times the second 2, times the third 2, oh, the 3. I say 3, but 1, 2 there. Third 2, and the last 2 right there. Okay? Then we have one pair of M that we circled, so we have 1 on the outside. And on the inside, we're left with just the lone singles, 2 in the M, 2 times M, and there we go. We have it kind of simplified out here. All right, what's left on the inside was the singles that were not paired up, and then the pairs combined to be on the outside, right? Because they represent one person on the outside, or one person, one number on the outside. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So we have 16m on the outside, times the square root of 2m on the inside. And that is our final answer simplified. The square root of 216 k to the fourth power. Okay? Well, 216, I know I can break down. It's an even number, so I'm going to use my calculator to help me out here. 2, so 216 divided by 2 comes out to be 108. So 216 is 2 times 108. 108 divided by 2, because it's an even number, I know it can't, is 2 and 54. 54 divided by 2, let's keep using my calculator here, is 2 and 27. 27 is divided by 3, to be 3 and 9. And 9 is 3 and 3. Okay? So now I've done my prime factorization of 216. I got 2 times 2 times 2 times 3 times 3 times 3. Now I have k to the fourth power. K to the fourth power can be broken down. Let's go 1, 2, 3, 4. Do 4 k's. Right? It's k times k times k times k. Okay? So that's kind of easier to see, right? K to the fourth would be 4 k's. So now I'm going to circle my pairs. I have a pair of 3's right here at the end of my prime factorization and a pair of 2's. Okay? I have one pair of k and 2 pairs of k. Okay? So now that I've circled all my pairs, when I write it out, all my pairs, when I represent the pair, I'm going to put on the outside, so that pair of 2's is just 1, 2 on the outside of my square root, and then this pair of 3's is just 1 times 1, 3 on the outside of the square root, and then I have a pair of k's times 1 pair of k, and then times another pair of k, and then inside the square root is just where the singles are left, singles, 2, they didn't get to go to the party, 2 times 3 is 2 times 3 right there, so we have 2 times 3, left over the singles that are inside the square root, and all the pairs got to leave the house to go to the party, okay, as a pair. So now we're left with, well, 2 times 3 is 6. Let's simplify that. So we have 6 here. K times k is k squared. And then 2 times 3 in the inside, the square root is 6. So our final answer is 6k squared times the square root of 6. Square root of 100 v to the third power. Okay? Well, 100 I can break down into my prime factorization. And that's, well, pretty simple, quick, right? 10 times 10. And I could keep breaking it down, and I will actually, but I can keep breaking it down. But if you know your pairs, I've already broken down 10 times 10. You can kind of circle that pair at this point. But for good measure, let's just do a complete prime factorization. 10 is 2 and 5, and this 10 is 5 and 2. All right, so 2 times 5 and 5 times 2. Okay, gives us 10. You'll see kind of why, for circling reasons, why I wrote it like that. V to the third power is just v times v times v. Okay, so now we have our prime factorization. 100 is 2 times 5 times 5 times 2, and v to the third power is v times v times v. Let's circle our pairs. So we have a pair of 5s right here in the middle, and then a pair of 2s. I circle like that. But I have my pair. I have a pair of v's. Okay, so when I break this down and simplify, okay, my prime factorization, or simplify out my pairs, pair of 2 on the outside of the square root, pair of 5 is on the outside, so we put 1 down, and a pair of v on the outside. Then we have the square root here of what's left, a single, which is just the only single left is a v. Okay, so now we simplify. 2 times 5 is 10, so we have 10v times the square root of v, and that is our final simplified answer. The square root of 80p to the third power. Okay, well, let's go do our prime factorization of 80. 80 is just 2 times 40. 40 is 2 times 20. 20 is 2 times 10. And 10 is 2 times 5. Pretty simple, right? So 80 is just 2 times 2 times 2 times 2 times 5. P to the third power is just p times p times p. Okay? So I've done my prime factorization of 80p to the third power, which is 2 times 2 times 2 times 2 times 5 times p times p times p. Let's circle our pairs. I have a pair of 2's right here, and I have a pair of another 2's right there. And the p's, I have one pair of p's right there. So every single pair, I'm going to put, to represent the pair outside of our square root, I'm going to put a 2 right here for this first one, times this one right here, this 2, times this p. Inside the square root is just the non-circled ones, the 5, that's right there, and then the p5 times p. So now I have rearranged the square root of 80p to the third power, simplifying partly to be 2 times 2 times p times the square root of 5 times p. So now let's keep going. 2 times 2 is 4. So we have 4p times the square root of 5p. And that is our final answer. The square root of 45. Oh, that's not a 5, that's like a p right there. 45p squared. Well, 45p squared, I want to do my prime factorization on that. So 45 is just 5 times 9, and 9 is 3 times 3. P squared is just p times p. So our prime factorization of 45 being 5 times 3 times 3, and p squared being p times p. So I'm going to circle my pairs. I have a pair of 3's right there, and a pair of p's. Okay, 5 is the Lone Ranger by himself, so when I write that out here, all right, write my pairs out here, so I have 3 on the outside, another pair of p right there. All right, there's a pair going outside of my square root, which is left over, the singles, which is just that 1, 5, and that is actually our final answer. Pretty simple and quick. 3p times the square root of 5. The square root of 147 m to the third times n to the third. Okay, we need to do a prime factorization here. So 147 we can break down. So 147, I use my calculator here. 147 breaks down to be 7 times 21, and 21 is just 7 times 3. Okay, now 147 being 7 times 21, and 21 7 times 3. We've broken down to all of our prime numbers, our prime factorization. M to the third is just m times m times m, and n to the third is just n times n times n. Okay, so what I'm going to do now is circle my pairs. I have a pair of 7's right here. I have a pair of m's, one pair of m's, and I have a pair of n's. So what's left is a 3 times an m and an n. So when I circle my pairs, I'm from the outside here. Outside of the square root, I have my 7 there. All right, so I have a pair of 7 represented by 1 7 right here. Pair of m's represented by this 1m, and pair of n's by that n right there. Then on the inside of the square root, I'm left all the singles, the 3 times that single m that's right there, times this single n right there. And I like to give myself a little extra space. We can see it's like 7m times n. Maybe put a multiplication sign there to make it not look like it's just like a cursive m with all these depends how close to this. Anyway, our final answer being 7mn times the square root of 3mn. Square root 200 m to the 4th power times n. Okay. Well, let's do a prime factorization on 200. Okay. Well, 200. It's up to you how you see it, but it's 2 times 100. Okay. And 100 is just 10 times 10. And 10 times 10 is 2 times 5, right, for that first 10. And this 10 is 5 times 2, or 2 times 5, whatever way you want to do it. Okay? M to the 4th, I'm going to break down here to be just m times m times m times m. And n is just by itself, that single n. It doesn't really break down. Okay? And so now I'm doing a prime factorization of 200 m to the 4th times n, which is 2 times 2 times 5 times 5 times 5, or 5 times 2, times m times m times n times m times that one n that didn't have a branch that comes down, the tree there. Okay? So now let's go circle our pairs. Okay? A pair of 2's right there. I have a pair of 5's right here, and a pair of m's, and another pair of m's. So now I've circled my pairs. I recognize my loners, which are the 2 and the n, the singles. So when I write my final answer, I'm going to put my pairs representing the outside. So these 2's represent 1, 2 on the outside. These 5 represent 1, 5 on the outside. We multiply that first pair of m's right there, and the second pair of m. Now we have the square root of what's left on the inside, which is this 2, times that n. Don't forget that n that was up there. So now let's simplify. 2 times 5 is 10. M times m is n squared. And then 2 times n is just 2n. So now we have a final answer of 10m squared times the square root of 2n. Square root of 75 x squared times y. Okay? Well, 75, I need to break that down by prime factorization. That's 5 times 15. 15 is just 5 times 3. So I've broken down to all my prime numbers. X squared is just x times x, and y is just by itself. So now that I've broken this down, prime factorization here, I'm going to circle my pairs. I have a pair of 5's, and I have a pair of x's. Okay? What's left is my 3 and my y. So every single pair, I'm going to put, representing that as a single on the outside, so 1 5 on the outside, 1 x on the outside. Inside the square root now is just the singles that had no pairs, the 3 and the y, 3y. This one's fairly simple. Our final answer here is just 5x times the square root of 3y. Square root of 64 m to the 3rd times n to the 3rd. Okay? 64 m to the 3rd times n to the 3rd. Well, I got to break that down. I got to break down to 64. 64 is just 8 times 8. And 8 and 8 are 2 and 4 each, right? Breaking down prime factorization, and 4 is 2 and 2. Okay, oops, an extra tree there. Okay, 2 and 2. M to the 3rd breaks down to be m times n, and n to the 3rd breaks down to be n times n. So now I have my full breakdown, my prime factorization of 64 m to the 3rd, n to the 3rd, which is 2 times 2 times 2 times 2 times 2 times 2 times m times m times n times n times n times n. And of course, m and n's had to be next to each other. Okay, so let's go circle our pairs. I have a pair of 2's right there, I have a pair of 2's right here, and a pair of 2's right there. Okay, m's, I have 1 pair of m's right here, and I have 1 pair of n's right there. So we take all of our pairs and represent them out. So a pair of 2 right here, single. Pair of 2 represents this 1, 2 here. This pair of 2 right there. And this last third pair of 2, let's run 3 again, it's just that 2 right there. Then we have a pair of m's represented here, and 1 pair of n, or n, there. The singles are left inside the square root. We have 1 m, which is a single, and 1 n, which is a single. Okay? So now let's simplify this. Okay, we're going to simplify what we have. Okay, so 2 times 2 times 2, 2 times 2 is 4, times 2 is 8. So we have 8 m times n, right, times the square root of m times n. And there we have it. Our final answer here is this 8m times n times the square root of m times n. Okay, oof. Square root of 16 u to the 4th times v to the 3rd. Okay. Well, let's break down 16 into a prime factorization. 16 is just 4 times 4, and 4 times 4 is just, or 4 and 4 are 2 and 2. Okay? So 16 is just 2 times 2 times 2 times 2. U is just, u to the fourth is u times u times u times u, and v to the third is just v times v times v. Okay? So I do my prime factorization of 16 u to the fourth, v to the third, which is 2 times 2 times 2 times 2 times u times u times u times u times v times v times v. Let's circle some pairs. I have pairs of 2's right there, pair of u's, 2 pairs of u's, and 1 pair of v's. Okay? Every single pair that we have, I'm going to put on the outside here, so I have 1 pair of 2, second pair of 2 right there. I have a pair of u, another pair of u's right there, and 1 pair of v. The only lone single is just that v by itself, so that's going to stay inside of my square root. Okay? So now let's go simplify this. When we simplify it, 2 times 2 is my 4. U times u is u squared, and then v is left over right there. So the outside simplifies to be 4 u squared times v. On the inside of the square root, we're just left that single v, and that is our final answer simplified. 4u squared times v times the square root of v. I know my square roots and v's look very similar. Try to keep them separate. Square root of 28, x to the third, y to the third. Okay? So let's go break down prime factorization of 28 first step here. 28 is 2 times 14, and 14 is 2 times 7. X to the third is just x times x times x, and y to the third is just y times y times y. Okay? So now I've broken down 28x to the third, y to the third by prime factorization to be 2 times 2 times 7 times x times x times x times y times y times y. Let's go circle pairs. A pair of 2's right here, I have a pair of x's right there, and a pair of y's right there. So for every pair we circled, okay, we're going to put a single on the outside, so 1 pair of 2 right there, 1 x on the outside, and 1 y on the outside. Okay? Now, so the pairs represent a single on the outside of the square root. Inside the square root, with our singles, we have 1 7 left over, 1 x left over, and 1 y left over. And so our final answer, now I can't simplify anymore, is 2xy times the square root of 7xy. The square root of 36 x squared y to the third. And that's all in the square root. Well, we need to take our prime factorization of this. So 36 we multiply to be 6 times 6. And you could be done there and see the pair there, but 6 is 2 and 3, and 3 and 2. Okay? So those 6's break down, so 36 is 2 times 3 times 3 times 2. X squared is just x times x, and y to the third is just y times y times y. Okay, let's go circle our pairs. I see a pair of 3's, a pair of 2's, right there, kind of weird circle, a pair of x's, and a pair of y's. And there's the one lone ranger y by himself. So every pair, I'm going to put a single number on the outside per pair, outside of the square root. So we have 1 pair of 2 right there, 2 times 1 pair of 3's right there, times 1 pair of x's, times 1 pair of y's right there. So we have the 2's, the 3's, the x's, and the y's, the pairs. What's left over is that 1 y stays inside the square root. Now we just simplify. 2 times 3 is 6. X times y is xy, or x times y. It really doesn't change anything. And the square root of y right there. And that, folks, is my final answer, 6xy, square root of y. Square root of 384 x to the fourth times y to the third. Okay? Well, what I want to do is perform prime factorization on 384. So 384 I know is even, so 384 divided by 2. Okay, and we have 2 times 192. 192 divided by 2 is 96, so we have 2 and 96. 96 divided by 2, let's just keep going here. 2 and 48. 48 divided by 2 comes out to be 24. 2 and 24. 24 divided by 2 is 12. And 12 divided by 2 is 6. And 6 is 2 and 3. Okay, oof. Got on a Tuesday. The x's can break down to be x times x times x times x, being x to the fourth, and y's y times y times y. Okay, let's circle some pairs here. Okay, one pair of 2's, two pair of 2's, three pair of 2's. Okay, then the x's, we have one pair of x's, two pairs of x's, and one pair of y's. Okay, so we write our pairs. For every pair, we put one representing that on the outside of the square root. So we have one pair of 2 right there, times this pair of 2's right there, times this pair of 2's, times the x's, one pair of x's there, times another pair of x's, times another y. The square root, what's left on the inside, is all the singles, which were the 2, the 3, and the 1y. So we have 2 times 3 times y inside the square root. So now let's simplify. 2 times 2 times 2 is 2 times 2 is 4, times 2 is 8. So we have 8. X times x is x squared. So we have 8x squared y times the square root of 2 times 3, which is 6, and then y is just left by itself. And there we go. Our final answer when we simplified this was 8x squared y times the square root of 6y. 7 times the square root of 96 m to the third. Okay. First things first, we need to break down 96. 96 in prime factorization here is 2 and 48. 48 is 2 and 24. 24 is 2 and 12. And 12 is 2 and 6. And 6 is 2 and 3. Okay. M to the third is m times m times m. Okay. So now let's go circle some pairs. We have a pair of 2's right here. We have another pair of 2's. Okay, and that's it. And then we have a pair of m's as well. So what we need to do is, well, that 7 just on the outside, so it's going to stay on the outside. For every single pair we see, we're going to write that on the outside. So let's see, we have my 7 that's sitting there. 7 times one pair of 2's times another pair of 2's. Let's mark them there. So I got them. Times a pair of m's. So representing again on the outside is just one m. Then everything that stays on the inside of the square root are the singles. 2 times 3 times m, right? 2, 3, and the m, the only one's not paired up. So now let's simplify. 7 times 2 is 14, times 2 is 28. So we have 28m here, times the square root of 2 times 3, which is 6m. And that is our final answer. 6 times the square root of 72x squared. Okay. Well, I want to see if I can break down 72. Well, 72 prime factorization is 2 times 36, and 36 is 2 times 18. 18 is 2 times 9, and 9 is 3 times 3. X just becomes x times, or x squared is just x times x. So now let's go circle our pairs. We have a pair of 2's right here, and we have a pair of 3's, and we have a pair of x's. Okay, we have 2. This 1, 2 is a lone ranger. So when we rewrite this, 6 stays on the outside because it's already there. And then each pair, when we multiply, we put a single one of the representing the pair on the outside. So we have 1, 2 there, one pair of 3's, and one pair of x's. What's left is the lone ranger by himself inside the square root, which is just the 2. So now we need to simplify. 6, or let's do this. 2 times 3 is 6. 6 times 6 is 36. So we have 36 right there. X times the square root of 2, and that is our final answer. Negative 6 times the square root of 150r. Okay. Well, 150, I need to break that down. Well, 150 can be really, what, 15 and 10? Pretty easy to see. 15 is 3 and 5. That's a 3 out of 5. 5 right there. And 10 is 5 and 2. Okay? So now, and r is just by itself. So now we have to find our pairs. The only pair I see is a pair of 5's. Okay? So when we simplify this out, the negative 6 stays on the outside. We're going to multiply that by one of our pairs, which is a 5. It's the only pair. Everything else, every other single element, stays inside the square root. So we have 2 times 3 times r. Okay? So we have the 3 times 2, 2 times 3, and then the r by itself. So now, let's simplify this. 6 times 5 is 30, and it's a negative 6, so it's a negative 30 times the square root of 2 times 3, which is 6r, and that's it. Pretty simple. My final answer would be negative 30 square root of 6r. 5 times the square root of 80a squared. Well, the first thing I want to do is see how I can break down 80. Well, 80 I know is, well, 2 times 40. Okay, and 40 is just 2 times 20. 20 is 2 times 10, and 10 is just 2 times 5. Okay, so I've done a prime factorization of 80. A squared just breaks down to be a times a. So now let's go circle our pairs. I have a pair of 2's right there, and I have 2 pairs of 2's. I also have a pair of a's. So now I've taken my pairs. Let's go fill them in. Now, 5 stays on the outside, and I'm going to multiply 5 by each one of these pairs, but just a single representation of each one of these pairs. One pair of 2's right there, 2, another 2, times 2, and then times the a. Right. Now what's left is the 5. It's on the inside the square root, so it's the square root of 5 right there. So now let's simplify. 5 times 2 times 2. Well, 5 times 2 is 10, times 2 is 20. So we have 20a times the square root of 5, and there we go. Pretty easy to simplify at that point, and that is our final answer. 2 times the square root of 125v. Okay. Well, 125v, okay, I want to break that down. It becomes 5 times 25, and 25 is 5 times 5. A lot of 5's there. Okay, so now let's go circle our pairs. I see one pair of 5's right there, and that's really it. So now when I rewrite this, okay, I'm going to put all the pairs on the outside with the 2. So there's only one pair of 5's. So we have 2 times one of the 5's represent a pair. So a pair on the inside is a single on the outside, times the square root of what's left on the inside, which is just 5 and then v. 5 times v. Okay? So now let's simplify this. 2 times 5 is 10. Pretty simple. Then 5 times v can be written as 5v. And so now our final answer is right here, pretty quick, is just 10 times the square root of 5v. Negative 8 times the square root of 24k to the third power. Well, I want to break down 24 to our prime factorization. It's 2 times 12, and 12 is 2 times 6, and 6 is 2 times 3. Okay, k to the third is just k times k times k. Okay, so now circle our pairs. I see just a pair of 2's and a pair of k's. Okay, everything else is just lone rangers by themselves. So now when I rewrite this, I'm going to put my pairs represented by singles on the outside. So we have negative 8 that stays on the outside from right there, times 2 times k, 2 in the k, times the square root of what's left over, the singles, 2 times 3 times k. Okay, so now let's simplify this. Negative 8 times 2 is a negative 16. K, right? So negative 16 and then bring the k, times 2 times 3 is 6, and just the k on the inside, and there we have it. Our final answer is negative 16k times the square root of 6k. Negative 4 times the square root of 192x. Okay? Well, I need to break down 192. Okay? 192 is, I know it's divisible by 2, and I don't know off the top of my head, 192 divided by 2 is just 96. 96 divided by 2 is 48. Those 2 times 48. 48 is 2 times 24. 24 is 2 times 12, and 12 is 2 times 6, and 6 is 2 times 3. All these 2's there. Okay? So now we've done our prime factorization of 192. Let's circle our pairs. I have a pair of 2's, 2 pair of 2's, and 3 pairs of 2's. Fantastic. Okay? So now when I rewrite this, okay, oh, there's no pair of 3's and there's no pair of x's, but there's single. So with negative 4 on the outside times each one of our pairs. I have 3 pairs of 2's. So we have 2 times 2 times 2, just 3 of them. All right, remember the singles represent the pairs. Singles on the outside of the square root represent the pairs on the inside of the square root. Times the square root of the singles that were left inside the square root, which is a 3 times an x, 3 times an x. So now let's simplify. 4 times 2 is 8, times 2 is 16, times 2 is 32. So we have negative 32 here, times the square root of 3x. And that is our final answer. 2 times the square root of 8p squared times q to the third times r. What we're going to do is break down each one of these elements here. 8 can be broken down to 2 times 4, and 4 is 2 times 2. P squared is p times p. Q to the third, which is q times q times q. And r is just r. Now we're going to circle our pairs. A pair of 2's, a pair of p's, and a pair of q's. Okay? What's left is a 2, a q, and an r. Don't forget that r. So now when I rewrite this, this 2 comes to the outside of my square root. Then each pair represents one element on the outside. So the pair of 2's, one on the inside, a pair of p's, one on the outside, and a pair of p's, one on the outside, and a q, one on the outside. The square root is what's left over, all the singles, 2, q, and an r. So we have 2, q, and an r. Okay? And so now we're going to simplify this at this point. 2 times 2 is 4, pq, and write p times q or pq, times the square root of what's on the inside, 2qr, and there we have it. Our final answer, 4pq, times the square root of 2qr. Negative 4 times the square root of 216 x squared y squared times z. Okay? Well, what I want to do is break this down. 216, I know it's divisible by 2, so 216 divided by 2 comes out to be 108. So 2 times 108. 108 divided by 2 comes out to be 54, so 2 times 54. 54 divided by 2 is 27, so we have 2 times 27. And 27 divided by 3 is just 9. So 3 and 9 is 3 and 3. Okay. From there, I can break down my x's to be x squared to be x times x, y to be y times y, and z is just by itself. So now I'm going to circle my pairs. A pair of 3's and a pair of 2's. Okay. I also have a pair of x's and a pair of y's. Singles are 2, 3, and z. Okay. So I'm going to write it over here. My negative 4 stays on the outside, and I multiply it by a single representation of each pair. 2 times 3, right there, times x times y. We stayed on the square root on the inside, all the singles, 2 times 3 and then a z, so 2 times 3 times a z. Keep that inside the square root there. Okay? So now, from there, we need to simplify that. Negative 4 times 2 is a negative 8, times 3 is a negative 24, so we have negative 24 xy times the square root of 2 times 3, which is 6, z. And there we have it. Our final answer is a negative 24 xy times the square root of 6z. Negative 3 times the square root of 24 a to the 4th b squared times c to the 3rd. Okay? Well, let's go break this down. 24 breaks down to be 2 and 12. 12 breaks down to be 2 and 6 is 2 and 3. A to the 4th is a times a times a times a. B squared is just b times b. And c to the 3rd is just c times c times c. Okay, almost ran out of room there. So I broke them all down, all parts here, all the individual parts here. So let's circle our pairs. A pair of 2's, okay? I have a pair of A's and another pair of A's, a pair of B's, and one pair of C's. So when I rewrite this, I have the negative 3 on the outside, and I multiply it by all my pairs. Pair of 2 times one pair of A times one pair of A times a B times a pair of C's. All right, remember, the pairs on the inside square root become singles on the outside of the square root. Got all my pairs. Now it's going to deal with all the singles that were left on the inside. 2 times 3 times just that C right there. So now let's simplify, okay? Negative 3 times 2 is a negative 6. A times A is A squared. B times C is just, we're going to write as BC. Then we have the square root here of 2 times 3, which is 6 times C. So my final answer here is negative 6A squared BC times the square root of B times C. 3 times the square root of 16x to the 4th times y to the 4th times z. Okay? So what I'm going to do is break this down. I'm going to break down 16. 16 is just 4 times 4. And 4 times 4 is just 2 and 2 and 2 and 2. X to the 4th is just x squared times x squared, which I can break down to be x times x and x times x. Same thing with y to the 4th, but I'll do it individually like this. Y times y times y times y, right? And z is just by itself. All right. Oof, got a lot of things we broke down here. So now let's circle our pairs. Pair of 2's, pair of x's, and pairs of y's, a lot of pairs. The only thing left that's not a pair is z, and be careful, don't forget that when you write our next step here, okay? 3 stays on the outside, and each pair represents a single digit or single number on the outside. So times 1, 2, times another 2 right there, times x, times y, times y, all right? Times now the square root, whatever is left inside the square root, which is just a z, the only single one by itself, that z that's right there. So now let's simplify. 3 times 2 times 2. 3 times 2 is 6, times 2 is 12, so we have 12. X times x is x squared. Y times y is y squared. Times the square root of what's left inside the square root, which is z. Okay? And that's it. That's our final answer. 12x squared y squared times the square root of z. Negative 2 times the square root of 48a to the third times b to the fourth times c squared. Okay? So let's go break this down. Well, 48, all right, I'm going to see how I can break down 48. 48 is just 2 and 24, and 24 is 2 and 12, and 12 is 2 and 6 is 2 and 3. A to the third is just a times a times a, and b to the fourth is just b times b times b times b, and c squared is c times c. Okay? So what I'm going to do now is circle all of my pairs. I have a pair of 2's right here, and another pair of 2's. I have a pair of A's, I have a pair of B's, a second pair of B's, and a pair of C's. Okay? So what I'm going to do is rewrite this negative 2 on the outside and multiply them by all of my pairs represented by a single element outside the square root. So we have one pair of 2 right there, another pair of 2's right there, so we have these two, times a pair of A's, don't forget that on the inside there, times another pair of B's, another pair of B's, times a pair of C's. What's left inside the square root is just all my singles, which is the 3 and an A. Just kind of careful how tricky it's in there, hit it. 3 times A. Okay, it's an A. I'm making it worse. Okay. So now let's simplify. 2 times 2 times 2, or negative 2 times 2 times 2 is a negative 8. We have A there, B times B is B squared, C, so we have our ABCs there, negative 8AB squared times C, times the square root of what's left inside the square root, just 3A. That is our final answer, negative 8AB squared C times the square root of 3A. 6 times the square root of 75, and the square root means bigger, MP squared times Q to the third. Okay? Well, let's go break this down. 75 breaks down to be 3 and 25, and 25 is just 5 and 5. 5. Okay? M is by itself, P squared is just P times P, and Q to the third is just Q times Q times Q. Okay? So now let's go circle our pairs. I have a pair of 5's, a pair of P's, and a pair of Q's. Okay? So what I'm going to do is I'm going to rewrite this, the 6 on the outside, and multiply all of my pairs as single elements on the outside. All right, so I have 1, 5 right there, then we have a P, then we have a Q, okay? And then inside the square roots is all my single values. My single values were just the 3. Don't forget that M that was up there, 3 times M times a Q being a Lone Ranger. So now let's simplify. 6 times 5 is 30, so we have 30P times Q times the square root of 3MQ. And there we have it. Our final answer, which is just 30PQ times the square root of 3MQ. 4 times the square root of 36 x squared times y to the third times z to the fourth. Okay? I'm going to break this down. All right, 36 is just 6 times 6, and each 6 here is 2 times 3, and 3 times 2. X squared is x times x. Y to the third is just y times y times y. And z to the fourth is just z times z times z times z. Okay, so I've broken this down, everything inside the square root here, or prime factorization. Okay, so now let's go circle some pairs. I have a pair of 3's, I have a pair of 2's. Oops, there we go. A pair of 2's right there. I have a pair of x's, I have one pair of y's, and I have 2 pairs of z's. The only thing left over, it's not paired up, is that single y right there. Okay, So now I rewrite this, 4 stays on the outside, and then I'm going to multiply that by each pair represented as a single outside the square root. So we have a 2, and then a 3. All right. Make sure we bring everything. We have an x, we have a y, we have a z, and we have a z. Okay? So we've got everything, the 2s, the 3, the x, y, z, and z. Inside the square root is just left over just a single y. Okay, the only one that was single there. The lone ranger, as I like to say. So now we simplify this. 4 times 2 is 8, times 3 is 24. So we have 24. X, y, right, just singles there. Z times z is z squared. So we're going to put a z squared there. Times the square root of what's inside the y, or inside the square root is just a y, not inside the y, it's just a y. And so my final answer here is 24xyz squared times the square root of y.
Minute Math. When you need help, you use Minute Math. Minute Math. When you need help, you use Minute Math. MinuteMathTutor.com.